Okay, today we're starting with a review on linear regression. When we type this into our calculators, with this being L1 and this being L2, we got a regression of equation of y equals, and the A as in the slope. I really wish the calculator would say M, because everybody else in the world uses M for slope. But the slope on this one was 1x plus 9. It gave us a nice little equation like this. That's a linear regression equation. We're going to do another one now with real more interesting data, and you'll be able to do more interpreting with it. So here's the data. We've checked, and a 5'10" person has a pinky length of 2.8 inches. Okay, I am not saying that that is perfectly exactly right. Okay, I'm making up this number. Now, logically, if people are in proportion, you know, KG, who's 6'11", is going to have a significantly longer pinky than a person who's 5'10". Okay, so I'm going to put that data in, and we're going to go with a 6'11" guy has, let's say, a 3.5 inch pinky, and let's say that a 5 foot guy is going to have a pinky of, let's see, what would you feel like is about proportional there? 2. I'll go with 2.4. It really doesn't matter that much. Now, if we were to put this data in exactly how you see it, what would be the problem? Units. It's inches. And one's in inches and one's in feet. What do you think would be easier? Changing my inches to feet or changing my feet to inches? Feet to inches. So then everybody use your big brain and don't put in 6'11". Figure out how to do that using math. And by the way, you can usually type your data in actually as a problem. Like in your little chart, you could type in 6 times 12 plus 11. Get what I did there? And I think your chart would take that number, calculate it for you, and you could do it right in the chart. Does that work? Can we verify that? Okay, cool. And you can always put parentheses in and stuff like that, but when you're all done, the chart number would be right then. You don't have to like make a separate one to chart. All right, I'm going to pause for a second while we get that data into list 1 on the calc. Okay, for those following along at home, we are putting in our data now. I need to move this over a little bit so I have more room for my calculator here. And I go to stat. First of all, you see the red button is stat, and then I hit enter on edit. And now I got to clear these lists. Beware, if you go up here, 2 kids this hour just wiped out list 1 like completely, like it's gone, like they don't have L1 anymore. How do you do it where you can clear it without actually losing the entire list? What do you think? Is it the clear button, or do you think it's the delete button? Okay. What if I just if they're saying I should clear the list, shouldn't I just hit the clear button on the list and enter, and there we go. If you DEL it, it will delete L1 and it won't be there anymore. You don't want to do that. Okay, so be careful. So I'm going up here. I'm going to delete my old data. I'm going to clear it. But you don't go there and delete it. It's just a little thing, but it really is painful because then you have to completely reset your calculator to get list 1 back. All right, so I hope you didn't type in 6'11". I hope you typed in, as I described it, 6 times 12, which makes it into inches, and then add 11 more. And so kg is, I added 1 thing, and I got to add 10 to that. So go up here, take my number. Why don't you just tell me what should it have been? 83, thank you very much. kg is 83. And then we go to 5'10", so that's 5 times 12. I'm just going to do it in my head. 60 plus the 10, 70. Is that right? All right. And then on to the next one, which is 5 foot, which is 5 times 12 is 60, and therefore it's just 60. And I have to have the same units on both sides to keep this thing working nice. 3.5 is next, and 2.8, and 2.4. Now think about this for a second. Do you think it would matter if I had started with the 5 foot guy and then went to the 6'11" and then the 5'10"? It would not matter. The order that you put this in doesn't matter. The tallest guy could be first. The tallest guy could be in the middle. But what would matter, of course, is if I rearranged and didn't put the 3.5 with the 6'11". If those weren't paired, that'd be a problem. All right, so now how do I do this? I got to go to stat. Okay, I got a question. Hand. Oh, is there not a decimal in there? How? Your eyes are very good. Nice. Thank you. All right, excellent. Now, if I go to stat, calculate, Linreg, which is number 4 there, if your screen is like mine, it's got a nice little list of things, and I put the Y1 right here. If yours doesn't come up like this, you would just type L1, comma, L2, comma, Y1. All right, for me, though, I got to find Y1 in here and put it on this. Right there, it's the capital Y1. I had a kid find a lowercase y1. I don't even know where he found it, but it does not work. Don't do that. Okay, so hopefully you got A is 0.048, etc. Raise your hand if you got the same thing for your A, and therefore probably the same thing for your B. Good. Last thought is that's an equation which relates chickens to frog population. True or false? False. Of course it's not about that. What does it relate? What to what? Height to pinky length. Okay, so that means I should be able to now ask you a question about that. Say we have a person who is 7'2". How long should their pinky be? I'm going to pause for a second while you think about that. If we have a person who is 7'2". How long should their pinky be? I'll pause while you try that. Okay, we're back. Explain to me why I can't just go to the table and my table as it currently is and find the right answer. Why is my table all messed up? I have it starting at 2000 because that's where my calculator was. I bet a lot of you had to change your table settings. In case you don't know that, you go up above the window, table set, and then where should we start? Well, what was the biggest number? KG was 83, right? Okay, so let's start about there because we're going higher than him. So if I start at 83, then now my table should look a lot better. And now I can just keep going until I find the 7'2" person, which is not 72. It's 7 times 12, and then plus 2, which was what? 86. I just go up to 86, and bingo, bango, bongo. I've got 3.62 inch pinky. All right, here's one that's a little more morbid. So in my backyard, I've found in a fire pit a pinky bone. And I reconstruct the pinky bone, and it appears to be a child's pinky at about 1.8. Because when you came over that one time and had the bonfire in the back. Oh, anyway. Okay, 1.8 inch pinky bone. Well, I want to know how tall the person was who owned that pinky. This does happen. They find bones sometimes in the woods. And they've got charts for this. Honestly, they do. They're like, okay, so if it's a female pinky bone and I measure this bone, I can go instantly, oh, I know the person was 5'4". And it's that accurate so that they can know for sure from one bone that, okay, it was a 5'4" female or whatever. And boom, you know, okay, that missing person that would happen to be 5'4" and female, it's probably from them. Okay, pinky was 1.8. Pinky was 1.8. All right. Give me 2 options for solving this. Or at least give me one, and I'll maybe see if somebody else has another. Yes, sir? Go on the table. All right. So I'm thinking I might not want to go quite a bit higher than 83. So I could have gone to the table settings, but I could just keep going until it gets to 1.8. It might be just about as fast. I'm getting close. I'm almost in the 1.9 range here from all the presses I've already done. Was close. Okay, now 1.79 is really close to 1.8. So would you agree it's probably about 48-inch tall person? A little taller than that, maybe. Okay, there you go. Tell me another way I could have done it. Yes, sir. Yes! I go to y equals, where I've already graphed the other one, and say y equals what? 1.8. And then, if I go to graph, why can't I see it? I can see one of the lines. Why can't I see the other line? All right, window. So let's look at the window. And my x values are ridiculous. So given my x's are more like between 50 and 90 or something, maybe I should change it to that. 50 to 90 for the x's, which is the, in this case, the heights. And then I go down, and my y values were also pretty ridiculous. My y values were between like 1 and 3 maybe, or 1 and 5 maybe at the most. Then if I say graph, I bet you I'll see a lot better data. Ooh, there's my stat plot is plotting my points, and my line went almost exactly through them, and then, okay, I can't see it where they intersect. So I have to move a little bit to the left. What does that mean on my window? Moving to the left. My x. My x min, I maybe should make it more like 30 or something. And now I should try graphing it. And now can I see where the two lines cross? Oh, yes, I can. And I'm going to go second, calculate the what? Intersect. All right, good. Okay, so I have to hit enter, 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 and it'll jump to the answer, which is about 48.14. It's more accurate than before when I said it was a little more than 48. Look at that, I can get exact. But we all, I hope you know, that these are not perfect. These are approximations. There is error involved in making that line. You can tell that it's pretty good, though, because if you look at these dots, they are pretty much on the line. So there's not much error to this equation. We can trust it pretty well. Okay, so that is linear regressions. How many of you feel comfortable now that you could do that? Okay, good. This actually could be handy in real life. You get some data, you can do real quick calculations with it to say, okay, I've had this pattern going on my test scores. I can see, like, if I keep the same trajectory up, you know, what should I get on my next test? You could use it for that. A lot of things you could use it for. I know there's a lot of variables involved in that. If you decide to fail your next test on purpose, you can throw it off. But all right, so I am done talking about linear regressions. Now, what are we talking about? Well, we've got a few things. First, I want to do a problem a little bit like we did yesterday. And by the way, we met as a pre-calc team this morning and decided, based on various reasons for various people, that we felt like we should give it an extra day before we take the test, because there's some, this is going to be a trickier test than average, and we don't want you to go in right before the end of the quarter and fail a test here. Also decided, just to be extra safe, we're going to push this test into next quarter, even though you're taking it on Friday, which is a day later. You'll have to deal with that personally later. You can always take it beforehand or afterwards, whatever. But we're taking it Friday, and then that test won't count in this quarter. It will go to next quarter. In the end, really, quarter grades don't matter that much. I mean, I know they matter to you right now, right this minute, but colleges, in the end, look at semester grades. So it really doesn't matter that much. But I know it kind of stinks to have your quarter grade go down right before you get that grade report sent home. All right, so here we go. This is an example of an equation that has a variable placed strategically within it. All right, I would like you to tell me what its vertex is. Now, by the way, there's two ways. You could do this by completing the square, or you could do this with that other little magical formula. What was that formula again? X equals what? Negative b over 2a. Now, I know it's more complicated because there's an a in there. But hey, this is the pre-calc level where we do honors. If it was regular pre-calc, we would not have done this with a variable. That's where this gets a little more challenging. I'll pause for a second while I give this a shot. Okay, to see if you're on the right track here, if you're using x equals negative b over 2a, then you know that b, in this case, is a. And so it's negative a over 2a, and then the a's cancel, and you get negative 1/2, right? No. What? A and A are not the same. What are you talking about? Yes? A is 3. You're saying A isn't A. I know what you're talking about. Okay. So I'll back up. Oops. I deleted it by accident. I actually just moved. Okay, there we go. So you're right. I was just messing with your head. So this is negative B, which is in this case negative A, over 2A, but A is 3, so it's 2 times 3, so it's 6. And there you go. How many of you had this right start to this? All right, now here's the challenging part. Do the y of it. If that's your x point, comma, what's your y? There will be a little bit of simplifying involved, probably some tears. It's a little painful, but you can do it. I'll pause for a second while you try that. All right, so by now, hopefully you figured out, you just needed to write this equation, except drop in that for the x. 3 empty spot squared plus a empty spot plus 5. And what do I drop in the empty spot? Negative a over 6. Negative a over 6. And now I actually just need to multiply this puppy out. So this part right here, the negative at least goes away. That's a good part. And it becomes a squared over what? 36. And then I times it by 3. So it's going to be 3 times a squared over 36. There's still some potential canceling there. Plus, and the negative times the positive makes it negative a squared over 6. And then plus 5. And now I could simplify this a bit. 36 and 3 kind of get along. 12 times 3 is 36, right? I can't explain what's going on there. Okay. That is not even my ringtone. All right. That's right. I just downloaded the new operating system for the iPhone, so that changed everything. Probably reverted it back to the old one. So 12 times 3 is 36. And why did I do that? Because now I can cancel those 3's. Final answer, a squared over 12 minus a squared over 6 plus 5. If I was really evil, I'd make you find a common denominator and add them all together. But I'm not that evil. So, not even that, what? Yeah, it wouldn't be that hard. I agree, it wouldn't be that hard. It would be, we'd use 12 as common denominator, so times by 2, and this is over 1, and then I times by 12 here, and times by 12 there, and there we go. It wasn't that hard. Okay, but that would be an example of, you already knew how to find its what was this called? Its vertex, there we go. Its vertex before when we had an A in there, but like, for instance, if you know this, here's finding the midpoint is easy if it's like that. Finding the midpoint, you average the x's, you average the y's. Remember that? But what if this is a P? Find the midpoint now. Give it a shot. This is exactly the kind of thing that the ACT likes to do also, because they know that just number crunching on a calculator, it's really easy to type this into a little formula and get your midpoint. But they want to see if you really know what's going on. So do you? What do you think, Mr. Greenshirt? How do you find the average of the x's and the average of the y's now? Exactly. That's it. Keep going. I'm just going to take that at 13 divided by 2. All right, awesome. That's it. Any questions? Okay. So last thing, and what we're doing for the rest of the time is we're taking a little practice test, a little practice test with a partner. And the partner part really does help. Okay, so if you refuse to have a partner, I can live with that, but you're hurting yourself. Having a partner really helps you to bounce it off somebody when you're like stuck, because these are not super easy. When you first look at it, you might not just know what to do. You might need to think about them for a few minutes. And the overall scores were, on average, probably a B+ last hour. So it's not like this is really, really tough. But it's a practice test and a formative assessment, if you will. You'll need a calculator, and you will not need your iPad. All right. I'll That's all I have for the video for today.